Okay, we're going to talk about reasoning, inductive and deductive. You could write books about both of these types of reasoning, so we'll not spend a lot of time on the two ideas, just a couple of ideas that they talk about in geometry. Inductive reasoning is where you come up with specific examples to come up with a generalization or a prediction. Deductive reasoning uses facts, rules, definitions, or properties to reach logical conclusions. Uh, this one right here is probably the only key word from here, conjecture. You'll see this in geometry, and it's an educated guess based on known information, just something that you're going to come up with based on something you already know. Yeah. Okay, so basic inductive reasoning is patterns. There's patterns inside of inductive reasoning like 4, 8, 12, 16, and of course 20. 20, 15, 11, 8 drops by 1 each time, and so this ought to be what? 6. Okay, you've got triangles, you've got 2, 3, 4. Next one's going to have 5 triangles, right? Okay, every other one's going to be shaded, and which way are they going to point? Up, right, down, or left? Yeah, you're right, down, okay? So if 10 people walk into a room and they all have cell phones, wouldn't you just want to conject or have a conjecture and say, oh my goodness, everybody's got a cell phone. Everybody's got one. But the counterexample would be, oh, little Jojo doesn't have a cell phone. Poor little guy. He's only 2 years old. He's got a little plastic one, but that doesn't count, right? So a counterexample is whenever you prove something wrong that somebody acts like is true. All right. So here's where we're going. These are basically steps in a proof. Geometry has proofs, and that's coming up here shortly. And so you start with a given, and then you end up at the end of the proof proving something true. And there are reasons, there are statements and reasons that go as as you go down the proof. So right here, this given would be a statement, and then the conjecture is going to be the reason, or what can come from the statement. And then the reason is going to be up here. Okay, so we've already talked about several of these concepts already. B is between A and C. Here's the picture. And A, B, and C are collinear. Okay, we've seen it many times. Okay, B is in between. It's not in the middle. It's just somewhere in between. So that means that the first part plus the second part equals to the whole thing. So your conjecture could be that AB plus BC equals AC. Okay, so what's the reason again? You should know it by now, but if you don't, know it now for sure. Okay, this is segment addition, right? Segment addition is when you add the two parts of the segment to get the whole segment, right? And you'll see this in proofs, and that'll be the reason right there. Okay, next. Oh, what if B is the midpoint? Now that's a little bit more specific, right, than between. So if it's in the middle, then isn't it true that AB and BC are congruent? They're the same size. So what could we have as a conjecture? Of course, we could say AB was congruent to BC, right? And the reason is always usually, if they have a vocabulary word in this given part or in the statement is what I'll call it, then that's usually going to be the definition. So the definition is the definition of midpoint. I mean, isn't the definition of a midpoint, if you have a midpoint in a segment here, then aren't the two parts going to be equal, right? So segment addition, midpoint. Next, we talk about angles. Same ideas, same exact ideas. We've talked about it before. Angles they can add, and you can also have one that bisects it and the two parts are equal. Okay, so what if M is somewhere on the inside of angle arc and there's a ray coming out of it, creating two different angles here? Okay, so if it's just somewhere in between there, then these two angles aren't necessarily congruent, but we do know they add together to be the whole angle arc, right? So we could say that angle arm, or measure of angle arm, whenever they put that M there, that means the measure of it. In other words, 60 degrees or whatever it might be, 35. Okay, so measure of angle arm, which is this angle, plus the measure of angle cream, which is this angle, is equal to the big angle, which is arc. Arm cream? Ew. Okay, so this is called, what are we adding? Angles, not segments this time, so it's angle addition. Okay, so the reason for this step that we just took was angle addition. Okay, now if RM bisects angle arc, so it chops it in half, ha! goes right down the middle, then what's true about these two angles now? Do they just add to be the big angle? No, no, no. It's more specific. They're congruent. They're equal to each other. So we say that arm is congruent to cream. Anyway, angle arm is congruent to angle cream by what? Okay, this is called a bisector. So this is angle bisector, the definition of angle bisector. Yay! So angle addition and angle bisector. On the previous screen, it was segment addition and midpoint. Same ideas, just talking about segments on one screen, and on this screen we're talking about angles. All right, so this is something we have not talked about at all. Not really. We've talked about the idea of that if it has a line over the top, then we're talking about the segment name, like this guy's AB and this is SITA. Okay, CD. Anyway, so AB and SITA are congruent. They're the same guy. I mean, they're the same size. They're congruent. But their measures are also equal, like 6 and 6. The way we write measures is with an equal sign, and we take the top off. Okay, it doesn't have the line, and it doesn't have the squiggly part. And I call it the hat off, okay? The hat came off, and which is that line there and the squiggly part there, and then that line there. So if the segments are congruent, the measures are equal. If the measures are equal, then the segments are congruent by the definition of congruent segments. Okay? If they're congruent, then the measures are equal. Okay? And you can say it with the converse first. Remember conditional converse? So you can say it backwards. If it was a converse, you'd say if the measures are equal, then the segments are congruent. Okay? They had the same concept about angles. Okay? So if these two angles are congruent, then guess what? Their measures are equal, right? So you put the little m in front, right, to signify that we're talking about the angle degree measure. Okay, this could be 40 degrees and 40 degrees. Okay, so ABSA, the angle, and DEF, the angle, Def Comedy Jam. Anyway, those two angles are congruent. Okay, so this one's congruent to this one, and so if the angles are congruent, their measures are equal. This is the definition of congruent segments. What do you think this one is? Definition of congruent, I don't know, maybe angles? Okay, so it's angles. So these are kind of weird concepts, but they're true. Next, okay, if DB, this line here, which is the whole line segment, and AC, this one here, are perpendicular. Do you remember what perpendicular means? A lot of people always forget. Parallel? No, 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 not parallel. Perpendicular. Okay, if two lines are perpendicular, don't they form a right angle here, right? Yeah, they do, okay? So if they're perpendicular, then DBC is a right angle. They usually pick this one on the right side up in the first quadrant or whatever. I don't know why, but they do. It could be, they could have picked any one of the four angles, right? Okay, so if they're perpendicular, then it forms a right angle. That's the definition. Like I said, it's in the previous statement. If there's a vocabulary word, then they use that one, okay? So the word perpendicular, so you say definition of perpendicular lines, okay? So if they're perpendicular, then it forms a right angle, okay? Next, if it's a right angle, like this is, if it's a right angle, then can we say something about its measure? Sure, the measure is 90. You put the little m in front. Measure of angle DBC is equal to 90. If it's a right angle, then it's 90. So what do you think this is the definition of? Yeah, previous statement says right angle, so it's probably definition of right angle, right? You could actually see this two steps in a proof. You could say if two lines are perpendicular, then they form a right angle. If there forms a right angle by the definition of perpendicular lines, then the measures equal to 90 by the definition of right angle. So it could be two steps in a row, right, in a proof. Okay, next. 9. Oh, you've seen this stuff. Angle 1 and 2 are supplementary. Okay, so what's true about angle 1 and 2? They add up to 180, and so it helps you to make an equation. You can state that they are supplementary, then you can write an equation, which you can manipulate later and, you know, substitute into it and do all kinds of stuff in a proof. Okay, so measure of angle 1 plus measure of angle 2 equals 180. All right, definition of what? Of course, supplementary. Okay, definition of supplementary angles. Two angles that add up to, two angles that are supplementary add up to 180. Next, okay, arm and cream again. Here we go. Okay, you got the box. So what's true about these two angles? They must be complementary, right? So arm and cream are complementary. Can we make an equation like we did up here? Sure we can. Just have to use arm and cream in it. Okay, so measure of angle arm plus the measure of angle cream is equal to 90 degrees. Definition of what? Not supplementary, but of course, definition of complementary angles. Very good, very good. Yay! All right, deductive reasoning is another time. Oh, I got to turn this thing off. Okay, die, 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 die. Bye.